Hi there, Lauren here. Have you ever looked back on something you've done in the past and realized in hindsight it wasn't exactly the smartest thing to do? Because that basically sums up humanity in a nutshell. Don't get me wrong though, as a race we have been able to pull off some incredible feats. That being said, the road to succeeding in those accomplishments has been rocky and treacherous and full of trial after trial, blunder after blunder. So yes, we have made some mistakes, and looking back on them we might not see what the logic was behind some of the things that we've done, and other ones, despite their being wrong, they still led to something even better. For instance, early medications, specifically essential oils. Now I know that there is a bit of a debate on the pharmaceutical usage of essential oils, so I'll just leave it at that there hasn't been a formal study on their effects. What they did provide was an early way to lead into the field of chemistry through a primitive form of distillation. Around 800 BCE, we start to see distillation appear. Distillation is a way to separate compounds. This can be used to identify components, obtain useful chemicals, and filter out unwanted compounds. In a hypothetical situation, let's take a look at solution ICK. It is made up of compounds I, C, and K. We are faced with the task of separating these chemicals. Now, substances are easier to separate when they are in different phases. Distillation takes advantage of this fact. By heating up the solution, we can take out the chemicals type by type. This is because we can assume that different molecules have different heats of vaporizations. The heat of vaporization is the energy required to turn 1 mole of a liquid into a gas. It is temperature dependent. A lower temperature means a lower thermal energy in the liquid. The lower thermal energy means that more energy will be needed in order to make the adjustment from a liquid to a gas. Since the transition is an endothermic reaction, a reaction that takes in energy, the heat of vaporization is positive. So behind me I have a cherry tree, and if you chop that down and split it all up, you get something along the lines of this. Cherry wood chips. Smells pretty good actually, but it's not really something that I'd use for perfume or flavoring. What I can do is try to isolate that essence of the cherry. Now this here is your basic distillation apparatus. I've been soaking some wood chips in ethanol for the past couple of days. The ethanol is taken in the scent and color of the wood. I've already placed a flask containing the solution on a heating unit. The ethanol begins to turn into a gas and rise up through the tube. This is because the ethanol has a lower boiling point than oil. Some of it immediately condenses on the side of the glass while the rest of it continues down the tunnel. The gas is forced into the heat exchanger. The heat exchanger is built with 2 tubes, one inside of the other. The gas and the condensed ethanol runs into the core tube. The outer tube is constantly being pumped with cold water. I've got the water stored inside of a milk can. It is being pumped with an aquarium pump. The water goes in through the white tube and out through the blue. The cold condenses the rest of the gas. We can see this because there is a greater rate of flow going into the separatory funnel than there is going into the heat exchanger. That means there is more liquid than there was before. The oils from the wood, on the other hand, remain in the flask. So here we have the essential oils without any of the ethanol. Yeah, that's strong. It smells like cherry. Really strong cherry. Sticky. As knowledge on artificial flavorings started growing, distillation was used as a way to find the different components within a taste. Unfortunately, chemists have come to find that flavors are a bit more complex than just pointing out which chemicals are in something and putting them together in the same ratios. 2 completely different compounds can trigger the flavor of a watermelon, even if they aren't actually present in watermelon. And some flavors, such as chocolate and coffee, completely puzzle chemists, and have yet to be replicated in the lab. Now, despite having more modern and accurate ways of separating chemicals from solutions, distillation still plays an important role in our world, whether it's making hard liquor or purifying water or anything else of that sort of general thing. Personally, I think it's really cool that something like this is still relevant after all this time. So far away.